Hey everybody. So today we are going to do this two sum question, and let's see what we got over here. Uh, Given an array of integer nums and integer target, okay, return the indices of two numbers such that they add up to target. Okay, so on the one hand, we have an array, and then we want to find two numbers that add up to target. Now, these two can be anywhere, right? So, like, we got an array, so these two can anywhere, right? So, the brute force method, what that would do is that we would try all the pairs, all the possible pairs, but of course that's not gonna be feasible because it's gonna be inefficient really, so we don't really want to try that. So there is another way we can do this, so let's look at that. First I wanna just write down this example here so I don't have to go over there again and again. And then target is na in, and let me just fix that. Okay, target is 9, and what was the output? Well, output is 0 and 1. Let me just write that here, and these are the what indexes, because 7 plus 2 is 9. Okay, so basically we have x plus y situation, right? And this equation tells us that these two numbers, right, would come from this array. This can be anywhere, right? And then when we add those, we get the target, right? So another way we can write this equation is this, right? Now the idea is that this is an equation, right? So we have the target. So uh, out of these three things, if we have two, then we can find out the third one, which would be y. So we have what? We have target, and let's say we have x. Let's say for the sake of argument, then we can find out y. How? Let me show you an example. So let's say we have target, which is 9. Then we know if we subtract 2, right? So we're going through the array and we get 7. At that point we gotta ask, have we seen 7? Well, because we're scanning the array from this side, right, from the beginning, so at this time we have not seen it, right? So that means we can say, okay, we haven't find the combination that we're looking for, and then we keep looking. So now the target remains 9, right? But now we are subtracting 7, so we moved our pointer from over here to over there, right? Now this gives us 2. Have we seen 7? So we ask that question again, right? And turns out we have seen. Now, as for how would we keep track of the stuff we have seen? Well, we can keep track of that thing in the form of map, right? So, first, what is it that we need to keep track of? It's the number, right? Okay, now you might ask, right? Or one might wonder, like in the value, what should we have? Normally we have true, right? That indicates we have seen something, but incidentally here we are going to have to return the index. So it makes sense to put the index here. So index at which we found 2, that would be 0. And the index at which we found 7, that would be 1, right? So now when we find the combination, then we can basically go back and say, okay, this is how these are the indexes. So you see the pattern here is, well, let's try to understand the pattern. Yeah, I just want to spend some time on that, because coding this thing will not be a problem, but perhaps we need to understand this pattern, because there can be other questions where this is used. Okay, so in all the questions, do we want to always write the equation and derive this? I think that would be prudent, because in some question we might not have this same e- expression on this side, right? So it can be different, but if we are deriving it every time, then of course that means we will not be making that many mistakes, right? So because we'll be utilizing of slow brain, so there is that. So now on to writing the solution. Let's try to write the solution. So, well, we gotta have a map, and I hear the set is faster, by the way. So maybe I should use set. What do you think? Hmm. Well, let's try the map first. But if I'm going to use set and I have duplicates, right? So that means, let's say 3 is appearing twice, but then the value would be overridden, right? But the same would happen in the case of map, so there's no difference there, but yeah, we would get some speed. So let's make it set. So we'll start iterating. Well, you know what, we can use the for off loop here perhaps. So this code is in JavaScript. So we have num of, let's say we get nums. Now here I'm gonna check if the set has the num that I'm looking at. No, but why would I want to look for that? No, I think we need to change this logic. So we first need to do target minus num, and this is the y that we get. Now we have to check, right? Because this comes from straight above diagram that we discussed, right? So now we're gonna be like, okay, set has y. If it does, then we are going to return. But what are we going to return? We are going to return the indexes. Why? Because we already mentioned that we need the indexes, because we in the question we are asked to return those, right? And where would those indexes come from? Well, those index would come from the set, right? Because we're keeping track of that thing there. So okay, so where is the other index? Oh, turns out if I'm using the for of loop, I can't really use the index, right? So let's switch to uh, for loop. That gives us more control. So we have I nums dot length, well, and then we have I plus plus. Okay, wonderful. And what is num? Let's define the num here. We nums at I. Okay. So here, what we must do is we get nums I. Well, no, we are going to return the index, right? So what are the two index? Currently, we're scanning, right? And I represents the current number that we're pointing to. So that is the index that we return, and then we have to get the index of the other thing that matched with I. So that would come from set dot get, and then we get I. No, should be Y. Well, when we do Y, the map will have the index stored. So we get that, and so this is the case where we have found the match. But let's say if we don't, then what do we do with the current number? Well, we put it in the set. So we say num, and then we store the index. That way, in the next iteration, we can check in the set to see if this thing exists. Now, the benefit of this approach is that if we were going to check all x and y combinations, that is going to require of n squared, right? So this is not really an efficient approach. But this problem that we did, it can be done in single pass, so it's much better.